We analyze our data with multiple methodologies. By Pearson correlation, the correlation coefficient between each input and output is observed. Coefficients are allowed to take values between -1 and +1. By hypothesis testing implementation, the average washing performance output value changed by changing the value of each input is observed. To do this, first the data is separated into two groups as efficiently washed and inefficiently washed. By linear regression analysis, the output value is predicted from the input value. Firstly, the data is separated into two sets, which are training set and test set. The program trains itself with one input and output parameter by using the training set. Then, it determines a regression line accordingly. Afterwards, test set is used for the validation of the model. By multivariate regression, the output value is predicted from the multiple inputs. Training and test set process still applies. Moreover, the backward elimination method is used to determine and eliminate the inputs which are not related to the model. By random forest, the output value is predicted from multiple inputs too. Training and test set process still applies. It gives a predicted value for output via the average of decision trees prediction values. After that, to validate our predictions, the R-squared method is used. It validates the prediction made by the model using the test set's real and predicted values. It takes values up to 1, which is the sign of the most efficient point. As consequences of our analysis, while the first rinse at middle low watt process time has the strongest positive correlation with the output, whose correlation coefficient is 0.3, the second rinse water amount has the strongest negative correlation value as -0.26. As it is seen, the Pearson correlation could not find any strong correlations since these values are not close to 1. According to hypothesis test implied for some of the inputs, the main wash process at high middle watt time has a positive effect on the output value, and mean of first rinse process time has no relation with the output. After implying the linear regression for each of the inputs, the R-squared test did not give satisfying results. This means the inputs do not have a linear effect on the output by themselves. After implying the backward elimination, the related inputs and their coefficients are determined by the multivariate regression. The first rinse water amount has the highest coefficient value. The R-squared method gives a higher value in this regression compared to the linear regression model. After implying the random forest method, the R-squared method gave a satisfied result, which is 0.8. The results show that the most effective input on the output is second rinse process time. Hopefully, Arçelik executives will be able to further improve the cleaning performance of dishwashers from now on.